Hi, this is Daryl from Mana. Today we're going to be touring the physical quantity service and looking at its powerful features for extracting and parsing physical quantities from text, putting them into a standard form, converting between units, and performing math with dimension-safe arithmetic. As of Platform Release 3.2.2, the physical quantity service has been completely rewritten to provide better scalability and performance. Its types and functions have also been refactored to provide 100% compatibility with the Q platform's function composition feature. Let's take a peek inside this service and see what it has to offer. The primary concept exposed by this service is the physical quantity kind, which represents a measurement with a numeric magnitude and a unit of measure. If you've used the Mana measurement service, this may look familiar to you. The difference here is that in the physical quantity service, the units of measure have far more information on how they're constructed. Each unit of measure might be constructed as a product or ratio of other units of measure, or by scaling by unit of measure prefixes. By carrying around these definitions with each unit of measure, we're able to do symbolic manipulation, and this allows us to do arithmetic with physical quantities, and to derive unit of measure conversions on the fly. The Mana measurement service and the physical quantity service have been designed to complement each other. In those cases where you need a simple representation of type-safe measurements, you can use the measurement service. And in those cases where you need to do symbolic manipulation, arithmetic, or unit conversion, you can use the physical quantity service. The function measurement to quantity has been provided to help convert between the lightweight representation provided by the measurement service into the full symbolic representation in the physical quantity service. Commonly used arithmetic operations can be found on the Arithmetic Operations knowledge graph. Here you'll find addition, subtraction, multiplication, and division, as well as scalar multiplication and exponentiation, and other useful functions. Using these arithmetic operations, it's easy to construct engineering computations using function composition. Here I've implemented the calculation for the absolute hydrostatic pressure at the bottom of a fluid-filled column, which is just the mass concentration or density times the length times the acceleration plus atmospheric pressure. And I can run this with the run dialog. In this way, users can perform dimension-safe computations with physical quantities in a low or no-code environment. You can find the comparison operations on the comparison operations knowledge graph. The supported comparison operations include traditional binary operations like less than or equal to, equality, greater than or equal to, or greater than, as well as minimum and maximum functions in both binary and n-ary forms. You could try these functions out using the run dialog, or you can use them to implement your own functions using function composition. The unit conversion functions can be found on the unit conversion knowledge graph. The function convert_to can be used to convert a physical quantity to any unit of measure that is dimensionally consistent. For example, here I'm converting the value of 1 foot into inches. Use of the explicit unit conversion functions is often not required because the arithmetic functions convert things to compatible units behind the scenes, and also provide the ability for the user to specify the desired unit for the output. As the final stop on our tour, let's look at the text processing functions. These can be found on the parsing and extracting knowledge graph. The parse function can be used to read a physical quantity structure out of its string representation. The parse unit will do the same for units of measure. And the extract function can be used to extract multiple unit of measure mentions from a document. The extract function is particularly useful when you want to scrape physical quantity mentions from text documents. For example, here I've written a simple function to read in a PDF document from the web and extract all the entity mentions in it. The document I'm using here is Lewis Carroll's Alice in Wonderland. Now that you've seen the powerful features that the physical quantity service has to offer, you're probably really interested in using it in your next project. To do this, it's as easy as searching for physical quantity in the search dialog and dragging the results into your project's inventory. Once you've done this, all the functions and kinds of the physical quantity service will be at your disposal. Have fun! If you enjoyed this video and want to learn more about the physical quantity service, don't forget to subscribe to the Mana Inc. YouTube channel and keep an eye out for our upcoming tutorials.